using functions and the formulas that might be associated with them for 2.2. All right. So, question 1 really just asks us to describe in words what's going on here with this function. And so we don't need to use tons of words. Point form is fine. But generally speaking, I might say that f multiplies its inputs by 3. Because x, that's the input, right? And so this is where input is found in our formula, wherever there is an x. And in theory, it doesn't have to be an x. It has to be whatever symbol is here. So if that shows up somewhere in the right-hand side of our formula, that's where our input is plugged in. All right, now for question B. All right, so g of x is equal to x over 2. And so, of course, this is our input this time, as is this one. And so what we have here is whatever input we have, we divide by 2 to get the output. And so I might say g divides its inputs by 2, or in half if you prefer to say it that way. All right. So then we get into functions that have multiple operations occur. So what do we have? H of x is equal to 10x minus 25. So very simply, h multiplies its inputs by 10, but then it takes 25 away one this time. Then subtracts 25. I'll try and write maybe a little bit more clearly. That handwriting is kind of terrible. I'm sure some of you guys are used to my terrible handwriting by now, but I think we could get a little better. All right. So lastly, we have d. We have our y of x function. It's equal to 4x squared plus 6. So what do we have here? We have this idea that this function does 3 things. It multiplies by 4, it squares, and it adds 6. And there's an order to this. If I knew my input, the first thing I would do is square it. Keep following BEDMAS, right? So we don't think about BEDMAS. So the first thing I would do is the exponent, the squaring. Then multiplying by 4, the multiply step. And then finally the adding step. So we might say y squares its input, multiplies it by 4, and then adds 6. Okay, so now let's do something with these functions. So question 2 asks us to just use these functions above. So if a function refers to function f, it means the rule for f is that we multiply by 3. And the rule for g is that we divide by 2, and so on. So what do we have here? Question 2a. There we go. So we're going to say, okay, we've got f of 25. Oops, that just says f of 2. F of 25. And so what we do is we rewrite 3 x. Instead of an exo, wherever there's an x, we replace it with the value 25. Okay. And so 3 25s is 75. So f of 25 is 75. And that's it. That's really all we have to do there. Okay. For b, we have g. So we have g of negative 18. And so what we do is we take the g function, and instead of an x, we write in negative 18 in its place. And so that says that g of negative 18 really simplifies to half of negative 18, which is negative 9. Okay, let's keep going. All right, so we've got h of 2/5. Okay, well, what does my h function do? Well, it takes my input, multiplies it by 10, right? So I'm going to write that 10 multiplied by 2/5, and I'm going to subtract 25 from that. And so we're going to have to multiply those fractions together, so that's okay. We know 10 is a fraction. It's 10 over 1, right? Okay. And so then we're just going to multiply fractions, the top by the top, bottom by the bottom. Oh, wait, actually, I can see that I can divide each of these by 2 diagonally. I might simplify them. A 2 and a 1, dividing them both by 5. And so what that really gives me is 4 take away 25. So h of 2/5 is just negative 21. Okay. All right, so we'll look at question D here, 2D. So we've got the y function, referring to the y function, y of negative 1.5. Now that's a decimal. I like to write my decimals as fractions, so I'm going to first rewrite this just like that. And then we're going to say 1.5, negative 1.5. That's the same thing as the negative 3/2. Now, maybe you have forgotten how we do that, how we take a decimal and turn it into a fraction. Well, that's fine. I'm going to show you a little trick for that, the calculator. So unless you have a Texas Instruments calculator, this is a Casio, and this works on most calculators, but I found it doesn't really work with Texas Instruments ones. I'm just going to type in the value, negative 1.5, negative 1.5, okay? And then all I have to do is press the fraction button. So I'm going to press the fraction button. Oh, no, sorry, haha. We have to press equals first to kind of store that value into the calculator. And we can see it's negative 1.5, shows up here, and then I just press the fraction button. And it tries to express this number as a mixed fraction. So that says, it's trying to say negative 1 and 1/2. But the calculator doesn't really have all of the pixels to do that, so it tries to express it, and this is the way it's trying to say it. However, if you see the second function of the fraction button has a capital D over, pardon me, a lowercase d over lowercase c. And as we know, D comes after C in the alphabet, so that's like a bigger number on the top than it is on the bottom. So I'm going to use the shift function to use the second function of this button, and say, oh, okay, it actually turns into negative 3/2. And so chances are pretty good your calculator will turn a decimal into a fraction for you, which is a useful tool. All right. So then I'm going to square this guy, negative 3/2. And so just so we're clear, negative 3/2 times negative 3/2. So we've got a negative multiplied by a negative, so that's going to give us a positive value. And 3 times 3 is 9, and 2 times 2 is 4. So I'm going to rewrite this as 4 times. And inside this bracket, now we've done the squaring, so we got 9/4. And we're going to add 6. Now, we got this fraction multiplication now, so we got 4 over 1 times 9 over 4 plus 6. And again, I can see diagonally that I've got these 4s, and we can divide them both by 4. We can cancel them out, right, and leaving a 1 in their place. And so that actually makes this 1 over 1 times 9 over 1, which is to say it really simplifies to 9 plus 6, or 15. So y of negative 1.5 is equal to 15. And there's our answer. All right. So let's take a look at 2e next. So we've got f, that's our multiply by 3 function. So f of x is equal to 3x, and I'm going to replace x with my input of a plus 3. And that's equal to 3 times a plus 3. Now, those brackets are really important, obviously. Both these guys are our input, so they're both going to get multiplied by 3, not just the a. So I'll distribute this 3 in, and I get 3a plus 9. So f of a plus 3 is 3a plus 9. And I've got h of negative 3/4. Now my h function multiplies by 10 and then takes away 25. So I'm going to have 10 times negative 3/4, take away 25. Now I've got this fraction, 10 over 1 times negative 3/4, and minus 25, right? Now I might divide these guys both by 2 and leave a 5 up here and a 2, because you can divide 4 and 10 by the value 2. So I've got 5 times 3. So overall, we're going to have a negative number. It's a positive times a negative. 5 times 3 is 15. 1 times 2 is 2. And then we take away 25. Now, maybe, because 25 is 25 over 1, I can see I'm going to need a common denominator. So maybe I can write it as 50 over 2 instead, just by multiplying that one by 2 and the bottom one by 2. All right, and then we get the value negative 65 halves when we're done. So h of negative 3/4 is negative 65 halves. All right. Okay, so to g, we've got h of x plus 5. Now, our h function, wait, we have another h function? Yeah, we do. Also multiplies by 10 and then takes away 25. So we're going to multiply that one by 10. We're going to remember our brackets. And then we're going to add, nope, pardon me, we're going to take away 25. All right, so we distribute this 10 into the set of brackets. We get 10x plus 50, take away 25. So h of x plus 5, 10x plus 25. And that can't be simplified further, right? Those are not like terms. All right, we'll do the same thing with the y function. So y of x take away 1. So again, remember, whatever's inside the bracket, that's the input, right? So we're going to say, okay, well, we're going to replace that x with x plus 1, pardon me, x minus 1. And square it, and then add 6. Now, we've got to do the exponents first, right? So it's going to be 4 times, so we've got x take away 1 times x take away 1 plus 6. So it's going to give us 4 times. And I'm going to write that whole thing in brackets, because that whole thing is going to get multiplied by 4. And so that's going to give us x squared, take away 1x, take away 1x, plus 1. And we have two like terms there, which can be grouped together. It's going to be 4 times x squared, take away 2x, plus 1, plus 6. So we're almost there. I'm going to distribute this 4 to all three of these terms. So get, lastly, 4x squared, take away 4 times negative 2 is negative 8x. 4 times 1 is 4, and then plus 6. So our last answer here is y and x take away 1 is equal to 4x squared, take away 8x, plus 10. All right, so we're getting there. So now we're on to these sort of backwards questions. Question I. So question I asks a question, okay, well, instead of an input that we're given, we don't know the input. We want to know what the input is, but we're given the output. We're told that this function produces 7. So what I would do is I would start by rewriting the function. F of x is 3x. And if it says f of x equals 7, I'm going to replace 7 for f of x. And then I'm going to simplify by dividing by 3. That's going to help me isolate my value of x. Just going to cross these guys out. We're going to get x is equal to 7/3. Oops, 7/3, like that. All right. So we're just going to repeat that process for these guys. And we're going to try not to get distracted by the fact that some of these questions might look challenging or confusing. We're just going to say, okay, well, we're going to write g of x function out first. And this says g of x is equal to pi over 2. So I can replace g of x with pi over 2. And we're going to try to isolate that x. So we're going to multiply both sides by 2. It's going to cancel these guys out and cancel these guys out. So overall, we just ended up with pi equal to x. And that's that. And maybe you could just see that by seeing that there's some value of my input that replaces x with pi. And really, it would just be pi, wouldn't it? That's the only thing that takes that and replaces it to make it pi over 2. Okay. So for what x does h of x equal 65? Well, my h of x function multiplies by 10 and then takes away 25 each time. So I'm going to replace h of x with 65. Is equal to 10x minus 25. Then I'm going to isolate this x, so I'm going to add 25 to both sides, because that 25 is further away from x than that 10. That cancels this guy out, and it leaves us with, looks like 90 on the left and 10x on the right. And then we're going to divide by 10, divide by 10. It tells us x is equal to 9. You know what? I just realized we're not really checking our work, so let's check that. It's going to have a checking. So we can check this answer by putting that value in for x and saying, well, what would happen if we have h of 9? So I would plug it in, and I would say 10 times 9, take away 25. So it gives me 90, take away 25, which gives me 65, which is the value of x, which is the value that h of x, the output, was supposed to give us. So 9 was the correct input. Okay. 2L. For what value of x does y of x, which is the 4x squared plus 6 function, which function does it give us 406? So I'm going to replace this with 406. 4x squared plus 6. All right, now things are going to get interesting. So I'm going to subtract 6 from both sides. And that gives us 400 is equal to 4x squared. We divide by 4. Divide by 4. Cancel that guy out. We get x squared is the same thing as 100. Now, equal sign is so small you can barely see it on that screen. All right, equals x squared. Now, we know the opposite of squaring is square rooting, right? Wrong. We need to actually say the opposite of square rooting is plus or minus the square root of 100. That is the actual inverse of squaring, although you might not have known that in previous grades. So that means there's actually going to be two answers to this question. One answer is that we're going to have positive 10, square root of 100 is 10, and the other answer is it could be negative 10. So what this says is that there are two answers. X could equal negative 10, or x could equal 10. So let's check that to make sure. So I'm just going to check. So I'm going to find out what I'm going to find out what y of negative 10 is. So I'm going to replace x with negative 10. All right. And so I'm going to square negative 10, which is going to give me 100. And I get 400 plus 6, which is 406. So we're happy. Negative 10 works. It's an x value that gives us an output of 406. Negative 10 is one of our solutions. Now, lastly, we'll check, what about y of 10? Well, that's going to be really the same arithmetic, except instead of squaring negative 10, we're squaring 10, but after that, all the steps are the same. So we still get 406. So negative 10 or positive 10 are both solutions. And often the way we write that is like this. X is equal to plus or minus 10. Okay. So on to the next one, 2m. For what t? I'm not going to write the question, sorry. All right, f of t is negative 12. All right, so let's start with f of x is equal to 3x. That's the function, right? So what does f of t equal? Well, f of t must equal, well, 3t, right? And then we know f of t would be negative 12. So negative 12 is equal to 3t. Okay. And then we just have to simplify for t. So we'll divide by 3, divide by 3. And we get t is equal to negative 4. All right. So we'll also check. So let's just find out what f of negative 4 is. We'll put in negative 4 for t in this function here. We're using this function because that's a t function, f of t. It really doesn't matter. These are placeholders, right? Okay. 3 times negative 4. So we get negative 12 as an output. So which is great. That was what we were supposed to get, negative 12. That's what the question asked. So t, the value of t that gives an output of negative 12, is negative 4. All right, so what are we on to now? 2n. All right, clocking away. 2n. For what r does g of r equal 24? So I'm going to write my g function. G of x is equal to x over 2. So what's g of r then? Well, it must be, we replace the input here with r. So it's going to be r over 2. All right, and we're looking for the value of r that makes g of r equal to 24. So we're going to replace 24 in here instead of g of r. And then we'll solve for r by multiplying by 2, and we get 48 is equal to r. And lastly, we will do a check. Is it true that when I put that into my g of r function, is it true that g of 48 gives me, what is my output supposed to be? 24. Let's just check. So I get 48 over 2, which is 24, which is what we were supposed to get. All right. How about 2o? For what c does h of c give 4.5? All right. So our h function is this one. 10x take away 25. And we're going to say, okay, well, what's h of c? What if I had c as my input? Well, I'm just going to replace x with c, because it doesn't really matter. It could be any symbol. All right, and now I can see that I'm looking for a value of c that makes h of c equal to 4.5. So I'm going to replace h of c with 4.5. That's going to give me 10c, take away 25. Now I'm just going to solve algebraically, so I'm going to add 25 to both sides. Add 25. Then that gives me 29.5 is equal to 10c, which is to say, divide by 10, divide by 10, cancels this guy out, and I get c. And this is the function of moving the decimal place over once when you divide by 10. So it becomes 2.95 is our value for c. Now, as a general rule of thumb, questions that ask or give you values in decimals, sometimes that's okay to give a decimal answer, but if the question gives you an answer in fraction, you should give a fraction answer. So we could also say 295 over 100, or I guess we should divide them both by 5. I get 20 on the bottom, I get God knows what on the top. Okay, so 300 divided by 5 is 60. So this must be 59. And I believe 59 is prime. So I think that's as simple as we can get. All right, now let's check. So I'm going to see what h of my c function, h of c, h of 2.95 is. Okay, it's going to be 10 times 2.95, take away 25. Oops. All right, now multiplying by 10 has a function of shifting decimal place over once. So it becomes 29.5, take away 25. And then I can subtract 25 from both of those, and I have 4.5 left. Okay, so that's correct. That's what I wanted it to be. All right. That means the value of c we were looking for is 2.95, or 59/20ths if you prefer. All right, 2o, so we'll do 2p. We're almost done. Okay, so for what k does y of k equal 42? All right, so my y function is y of x is 4x squared plus 6. And remember, it doesn't matter what the symbol we use for the input is, only that we're consistent, so I can replace it with a k. It's equal to 4k squared plus 6. And then I'm going to replace y of k with 42. And then I'm just going to solve algebraically. Subtract 6, and I get 36 is equal to 4k squared, divide by 4, divide by 4. And I get k squared is 9. Now, there are two values of k that are such that I can square them and get 9. So to find them, I need to take the positive and the negative square root on both sides. That's the inverse of squaring. It's actually positive and negative square root. And so that tells me we have a value k here, and on the left we have plus or minus 3. So that is to say, k is negative 3 or 3. Either one will give us an output of 42. I mean, supposedly, let's just double check. Oops, that's not how you spell check. That's okay. So we'll put in our y function of k, and we'll try 3 first. That's going to be 4 times 3 squared plus 9. So 4 times 9 plus 9, which is 36 plus 9, which is 40. That's supposed to be 6. Pardon me. And that gives us 42, which is the output we were expecting. Right? The question asks what value of k gives us 42 on the output. Now we can also check y of negative 3, but we're going to notice that as soon as we square that negative 3, the math becomes the same as it was in the previous check, right? So it must also equal 42. So that's why there's two different answers that can both give you an output of 42. And remember, that's legal, right? You're allowed to have two outputs from the, you're allowed to have the same output, given two different inputs. It's just not the other way around. All right, I unexpectedly used a lot of paper here, so I'm going to dig out another piece. Give me one sec. One of these days I'm going to make a sign that says that I'm having technical difficulties when I'm off screen while doing things. Like they do in The Simpsons. Okay. Last questions. 2Q. Alright, so Q asks us for f of 2n. So we know our f of x function gives us 3x. So what's f of 2n? Well, that's going to be 3 times 2n. So f of 2n is the same thing as 6n. Right? Okay. Now, it says that we're looking for a value of n that gives f of 2n equal to 20. So that's saying that this value here is going to be equivalent to 20. Something tells me that's not going to scan very well, so I'm going to go over that in blue. Equals 6n. We're going to divide by 6. And I got n on the right, and I can simplify the top and bottom by dividing it by 2. That's going to give me 10 thirds when I'm done. All right. So I'm going to punch that into my original function and make sure that makes sense. Is it true that f of 2n equals, so that's going to give me 6n, right? Okay, so that's my function that I'm using to check, and then I'm going to replace n with 10 thirds. So what I really want to do is say, yeah, 2 times 10 thirds is equal to, I'll replace that n with 10 thirds, so 6 times 10 thirds. All right, so is that right? Is that going to give me, let's just find out. F of 20 thirds gives us 60 thirds. And I can divide the top and bottom by 3. I'm actually going to rewrite that as f of 2 times 10 over 3. It's the same thing as 20 over 3. But I think it kind of more clearly says 2 times n than this one. That might be a little confusing. And really, this is just check work, right? This is just for us. So we can write it in whatever form helps us see whether our answer is correct or not. Okay, and I can break 60 into 3 parts. I can think of how an hour breaks into 3 even sections. That would be 20 minutes each, right? 3 groups of 20 make 60 minutes. All right, so it looks like f of 2n, when n is 10 thirds, gives us 20, which was exactly what we were asked. So 10 thirds is the correct value for n. All right, last one, 2r. So for what value of w does h of 3w take away 5 give us 12? So first I'm going to write my h function. H of x is 10x take away 25. All right, and well, what about h of 3w take away 5? 3w take away 5 is going to be 10 times 3w take away 5, right? And then we're going to subtract 25 from that. So I'm not going to just keep this as it is right now on the left. On the right, I'm going to distribute this 10 into the set of brackets. This is going to give me 30w, take away 50, take away 25. So h of 3w take away 5 is equal to 30w take away 75. Right? All right. Now we were looking for a value of w that gives us 12 overall as an output. So this whole thing should be equal to 12. So we'll just replace it with 12 and do a bit of algebra, see what we can do here. So we're going to add 75, and that's going to cancel those guys out. So we're going to get 30W on the right. And on the left, what do we have? 787. Well, this isn't looking good. Something tells me I might have made a mistake. Maybe not. Let's just see how this goes. So I'm going to divide by 30, and so I get W is equal to 87 over 30. Now, I can see there's a trick here to know if we can divide these guys. The question is 87 prime, right? It's obviously not even. We can't divide it by 2. Can we divide them both by 3? So we can divide 30 into 3 parts, right? 3 groups of 10. But 87, well, we have this trick, right? We can add 8 plus 7, and that gives us 50. So if we add the digits of a number, we get some new number, which is 15. If that number can be divided by 3, well, so can 87. So actually, we can divide the top and bottom by 3. And that gives us 29 on the top and 10 on the bottom. And 29 actually is prime. Okay, so when I get a number like this and I get some really big, weird prime, if I have to ask if a number is prime in my fraction, because I'm not sure, that makes me think maybe I made a simple arithmetic error somewhere. And that happens sometimes. So I'm going to just check to make sure I was correct. So I'm going to replace W with 29 tenths. So I'm going to say, okay, I'm going to start with my function here, h of 3W take away 5. And I think I'll use my simplified one here. So I'm going to rewrite it as 3W take away 75, right? Now I'm going to replace W with 29 tenths and see what happens. All right, so h of 3 times 29 over 10, take away 5. Okay, replacing W with 29 tenths gives us an output of 3 times 29 over 10. What is happening here? I must be wrong somewhere. Add 75, divide by 30, divide by... This is really bothering me. All right. I just have this feeling. You know, you do enough math, you just get a feeling. There's something that's not adding up. All right, well, I'm going to have faith, you know? I'm just going to have faith that everything works out. And maybe it won't. What's happening? All right. So, I don't know how I feel about this. All right, 329, so that's got to give us 87 over 30. We're going to subtract 75 from that. What? Okay. There's an error somewhere right in front of me. Oh, God. Okay. Okay. That was supposed to be a 30. W, take away 17. 30, which multiplies by 29. So that's, okay, guys, we're back on track. Okay. Take away 75. All right. 3 times 29 over 10, take away 5. Okay. So, okay, it looks like this is going to work out, actually. That 29 tenths, despite it being a weird number, looks like it's going to even out. I can divide the top and bottom with this fraction I'm multiplying by 3. Nope. By 10. And you can divide them both by 10, but you can also do this trick of just crossing out the zeros. Maybe you've seen that before. So it gives us 3 times 29 on the top, which is, as we talked about earlier, 87. So we're going to 87 over 1 times 1, which is 1. So I'm not going to write the denominator. 87, take away 75. So h of 3 times 29 over 10, take away 5, is equal to 87, take away 75, which is 12. So we're in good shape. That is what we were supposed to get as an output if we put in 29 over 10 as a value of w. Okay, and that's it, guys. Those are all the practice questions, so good luck, and let me know if you have any further questions.